Hey guys, so this lesson is going to start off being about circles and arcs. So we're going to start off with just some discussion around this drawing and talk about vocabulary and go through some important terminology. And I hope you have a good time with this. First and foremost, here we have a circle. This is the shape we've all become very familiar with. We know that this is what a circle allegedly looks like. The circle actual part of this is the part in blue pen going around. If I'm talking about where the word circle is written, it is not on the circle. The word circle is actually inside of the circle. The circle is all of these points. It doesn't include the center. So the first thing we're going to define in our important terminology is actually circle. So a circle is a set of all points equidistant from a given point called the center. So all of the points on a circle, on, not in, all of the points on a circle are the same distance away from the center. So that could be a fixed point. This is a fixed distance, and this is an infinite number of points that land right along there. Now I have this little star next to the word center because we have a little bit we could say about a center. So circles are named by the center. Circle T is shown above. So the name of this circle would be circle T because its center is at point T. The next word we're going to define is diameter. And we're kind of going to have another word thrown in here, a little mini definition. So diameter. The diameter is a segment. A segment we defined earlier in geometry. A segment is a straight piece of a line where it ends on both sides. It doesn't go on indefinitely. A ray would have an arrow where it goes on forever in one direction, and a line has arrows on both ends. So it's a segment. A segment with both ends, like we said, it ends on the circle, also known as a chord. So this definition so far, a segment with both ends on a circle, that's really only saying to you, oh, this is a chord. Now, what I can do is throw a little extra in here. So what am I going to throw in here? I'm going to highlight the word chord in yellow. And a chord, if that's the only requirement, a segment with both ends on the circle. Well, that means that this right here is a chord. It's a segment, and both ends are on the circle. So a chord does not have to go all the way through the middle. However, a diameter is a chord that does pass through the center. So continue with this definition. However, the diameter must pass through the center. Sometimes we also say, instead of pass through, we might say it must contain the center. Next, the next word we're going to define is radius. A radius is a segment with one end on the circle, again, on the circle, and the other at the center. So a radius will always be half the length of the diameter. Think about their definitions. These are commonly mixed up, not because people find it confusing, but because you really learn them at the same time. And when you read one word, you kind of assume the other word sometimes and fuse them together. So really be mindful when you're reading words like radius or diameter versus even circumference and area, perimeter and area, length and width, base and height. Sometimes it doesn't matter, and sometimes it does. So you want to make sure that you are very, very mindful of this. Next, the next word we're going to define or phrase are congruent circles. Congruent circles have congruent radii. So congruent means they're exactly the same. So if I were to use this right here to trace a bunch of circles, okay, if I were to do that, these would all be congruent circles. It's from a candle. They would all be congruent, and they also all have the same radius. If the radius is really based on the definition, is a big part of the definition of a circle, well, it's what determines the size of the circle. If you've ever used a compass, if you've ever just swung your arm around at the blackboard, chalkboard, dry erase board, smart board, whatever board you have, if you've ever used a piece of string and maybe a nail, and you hold one end down and you spin it around, that fixed distance and that fixed center point is what creates a circle. So if we have congruent circles, they have congruent radii. Important piece of information. Next up, we have central angle. An angle whose vertex is the center of the or a circle. I didn't know which article to use, sorry. Central angle, an angle whose vertex is the center of the circle. So if its vertex is the center of the circle, then what thing could possibly be the sides of that angle, the adjacent sides to the angle? Could be the radius. Doesn't have to be, but could be. And I say it could be because the radius is a segment. If it were a line that just happens to overlap the radius, or if it's a shorter segment, I mean, it's also a possibility. What else? Next. Arc. Arc is a part of a circle. So you really have to remember, the circle is not like a plate. It's not something that the middle counts as part of the circle. The arc is the pen that goes around, or the circle itself is the pen or pencil that goes around. It's all those points that make that look, right? That shape, that figure. And an arc is just part of a circle. So an arc maybe just goes from, say here to here. That's just an arc, okay? Next up, we have a semicircle. So a semicircle is actually a type of arc, and it's a specific type. This type of arc is actually half of a circle. So for example, I said MH, and I put this little crescent-looking rainbow shape above it, and that's the symbol for arc. Arc, MH. So we go over here, where's MH? MH are the endpoints of the diameter. So the arc over here, we might be able to even say MAH. I probably should have written it with 3 letters. And MH would really then be that one if there's no other point, and MAH would be that one, but they're the same measure, they're the same length. Okay, next after that, well, if we could have a semicircle, that's exactly half of a circle. Well, what about something like this? A minor arc. A minor arc is smaller than a semicircle. And make sure you're writing than, T-H-A-N, and not then. Then is like, next. Then we learned about circles. Then we're comparing something, okay? So smaller than a semicircle. For example, AH, arc, AH. So let's look up here. There's A and H. That means I'm describing it this way. Well, how would I know that maybe I mean this one, AH going around that way? I have to somehow differentiate that. So what are we going to do? We also have a major arc. And look at that, AMH. So it is AH, but I add a 3rd letter in the description in its name to show that we're going around the long way to get there. And that's what makes this one a major arc, major versus minor. It's bigger, and it took the long way to get there. Now we're going to talk about arc measure. The measure of a minor arc is equal to the measure of its corresponding central angle. So here is the center of the circle, give or take. If I wanted the arc measure, the measure of this minor arc right here. The measure of an arc, I have to be able to define this curve. And this curve is defined by the circle on which it rests based on the radius of that circle and the angle measure of the central angle that corresponds to that arc. Okay, so an arc measure and an arc length are not the same thing. An arc length would be asking us, how long is this? This is arc measure. We're asking about, so for example, if I call this DEB, I'm going to name this angle theta, or I can call it angle DEB. So that would mean, I need a way to measure this also. So the minor arc is going to be dB. That's the minor arc. The measure of it, M of dB. What about a major arc? Is there a difference? Should I be describing this differently? How am I supposed to describe a major arc if that's how we describe a minor arc? The measure of a major arc is the measure of the related minor arc subtracted from 360. I need some notation as well. I'm going to have to put a point somewhere over here. The measure of, I'm going to follow this definition, the major arc, DTB, is the measure of the corresponding minor arc, or the related minor arc, subtracted from 360. We forgot semicircle. The measure, again, the measure, we're talking about the way the curve exists. The measure of a semicircle is 180 degrees. So adjacent arcs are going to be next to one another. Arc DB is adjacent to arc DT. That the measure of arc DB plus the measure of arc DT, as long as they're adjacent, they have to be adjacent. They can't just be, two different arcs in two different circles, okay? It will equal the measure of arc BT. The circumference, some people will simply describe it as the perimeter of a circle. The number pi is actually the ratio of the circumference of a circle and its diameter. If that's the definition of pi, what does the word is mean in math? Is means equals. Any form of the verb to be means equals. Pi is a ratio, which is a proportion, of the circumference. I could use the letter C to stand for my circumference, and its diameter. I could use the letter D. Now, what if I wanted to get C alone? Well, I can multiply both sides by D. These reduce. C equals, let's put pi in front, pi D. But I don't like to use diameter and radius. I like to narrow it down to just using one variable. I don't want to have too many. So let's swap out the diameter. Diameter is equal to the radius in which way? They are related. There's a relationship between them. But how are they related? The diameter goes all the way across, and the radius is only half of that. So the diameter equals 2 times the radius. So if I fill that in for diameter, and I swap this around, circumference equals 2 pi, went in for diameter, r. Now, circumference is a one-dimensional measurement. Circumference is the distance around the outside of the circle. A distance is a one-dimensional measurement, so you won't have two variables here, and you won't have a second power. So it does make sense that we only have r, and r is to the first power. I know pi doesn't look like a number, but pi is actually a constant, just like 2. R is a variable, just like circumference. The letter that's usually alone, depending how we set things up, depends on the letter on the right side of my equation. C depends on R. Circumference depends on the radius. Well, how big is the circumference? Well, it depends. How big is the radius? Next, we have arc length. Arc length and arc measure, you have to keep these two things separate. Arc length is a fraction of the circumference. Now, if I called arc length something, maybe I call arc length S. Now, if you've taken calculus or physics, you may have seen, and you probably haven't if you're watching a geometry video, but you may see that position and in certain circumstances and arc length is represented by the letter S. The reason we use the letter S to represent arc length in this case is the Latin word for size, which is also the word for length, is spatium. And so we use S for arc length. So we're going to use S right there. S will equal, arc length is any form of the verb to be in a word problem or in a mathematical expression means equals. So equals a fraction. Well, what fraction? I don't know. A fraction. So I'm going to have a fraction of means to multiply, of the circumference. Now I could put a C here, but I could be more specific and put 2 pi r and just get right to the point, because chances are we're not going to know C. You'll probably know the radius before you know the circumference. So arc length is a fraction of circumference, certain part of it. Now how do we figure out what fraction? Well, we put an angle. Earlier I mentioned theta. Theta out of 360 is a pretty good way to decide just how much of it it's taken up. It's like a pie chart. Get it? Pie chart. Do you get it? No? Not funny? Okay. So if you even have a piece of pizza pie. So you eat 1 out of 8 slices. Well, you decide how much you ate based on how much there was. Since we know that we have 360 degrees in a circle, then we can say that the arc length is a certain degree measure out of all 360 degrees of, which means times, 2 pi r. And then don't forget, spatium is the word in Latin for, and I may be pronouncing this wrong, I never took Latin, for size or length. And that's why we use S a lot of the time for arc length. I mean, A is sort of taken. We have area, we have apothem, got a lot of A's. So now what's this going to look like in a picture? Well, I have a radius right here, and maybe another radius right there. Between those two radii, I have some angle. And I want to know, how long is this piece of arc? Well, I know how to find the whole circumference. So this will be theta out of 360, that angle measure of the whole circumference, 2 pi r. And there we go. So arc length is a fraction of the circumference. Arc measure is equal to measure of the central angle. Measure length. Measure, M has these little humps over here. We use those to represent our arcs, you know. And length, we draw L for a line. I don't know. I'm trying to think of something. You could think of something more clever to help us remember the difference between arc length and arc measure. I'm open to ideas. Mine's not the best right there. I just remember after years of doing it, but I know everyone's always looking for a trick to remember. I know it seems easy right now, but it's one of those things that people jumble up.